1, 2, testing. All right, let's hope everybody can hear me. Right, so this talk is going to be a little bit different than this previous talk, which was quite technical on a quite detailed level. In this case, we're going to take a helicopter ride quite high up and look at some different types of code base management and also some other things that don't necessarily have anything to do with code base management, but I'm going to mention them anyway since I'm here. Before I go to the story, a quick introduction, since this is my first time talking at any meetup. My name is Holmström. I'm married, I got 3 kids. I graduated from Åbo Academy University here in Turku in 2009. A couple of months later, I joined Vaadin, or as IT Mill as it was called back then, and I've been working there ever since. So I'm now on my 14th year, if I calculated correctly, working for the same employer. I've been working with services the entire time, so I've been doing consulting gigs, helping other companies to build software with Vaadin. And I'm also been involved in project deliveries where we are the guys who are actually writing this code that's going to end up being used by the end users. And this is a story from one of those projects. Like I said, this is not a technical talk, although there was going to be a little bit of technology. This is a Java project. So if you know Java, you probably have a better idea of what I'm talking about than if you don't know Java, but most of the main topics should be quite like technology agnostic anyway. This also isn't a talk about how you should do things. This is a talk about what happened and why. So this is a true story. I've used some artistic license and maybe changed the order a bit. I've left out some stuff either intentionally or because I've forgotten about it, because it's been a long project. But I haven't made anything up. That I can promise. Some context that you need to know before we go into what actually happened and why. The customer in this case is a government agency. I'm not going to say which one. It's not in Finland. It's another European country. And this customer is tasked with lots of duties, but one of the things is to distribute financial support to non-profit organizations. And the way they distribute this financial support is through something called a scheme. Now, a scheme in this case is our own English translation of a domain term in another European language, and there wasn't an English translation, so we had to come up with something since the project was done in English. So we chose scheme. Basically, it's a regulation. So it's made by the politicians, and it states like who is eligible to apply for money, when can you apply, what information do you have to provide, when will your application be processed, how can you appeal, how much money will you get, when will you get it, and so on and so forth. The schemes can be quite different, but they all follow a similar process, which is this. So the applicant organization will start by filling out an application form, and then they will submit it, and then eventually that form will get processed either automatically or manually by a government officer. Eventually, we will reach a point when money needs to be paid out. So then we're paying out some money, and then we're sending a letter to everybody who's applied, and they will say either that, yeah, you got some money, or no, you didn't get any money, and then finally they can appeal, and then we'll have to do another processing and see that will they change their minds or not. So that's basically all the context that you need about the customer and the type of project. So let the story begin. So our original task was to build a system for submitting these kind of fund requests or applications and processing them. And we were supposed to support 2 schemes. One that was quite large and complex, and another one which was significantly smaller and was basically considered a small subset of this larger one. And they also wanted this to be possible to be usable as a platform for future schemes if any future schemes would show up. We would have to integrate with many different external systems. We would have to support automatic processing of requests in order to reduce the workload on the officers. And in a sense, this system was quite easy from the perspective of availability, scalability, security, because this was not a critical system, so we didn't need to support high availability. And the user loads were very low. We're talking about like tens of simultaneous users at a time. So we didn't have to worry about scalability either. And the data was mostly public. So once this application round closed, they will just release everything. So we didn't have to worry about sensitive data, GDPR, and so on. The plan, how to do this, was that we were going to build two separate applications. So we were going to build one application form app, as it's Java app, and then a back office Java app, and they would all be in the same Maven project structure. I assume everybody knows what Maven means. And in a single Git repository, these two applications would both be self-contained Spring Boot applications. We decided to go for modular monoliths because we figured that we're on a tight schedule, we know how to do this, so they're probably going to be the fastest approach. No, they weren't, but we're going to come to that later. And we are lazy developers, so of course we're going to reuse as much code as possible, so we're going to introduce this so-called shared kernel, which is a term coming from domain-driven design. So that we could share some code between application form and the back office. And all this was then stored in a private GitHub repository. We had pull requests, code reviews, and so on. And the development team consisted of both developers from Vaadin and also the customer's own developers. So it was a joint development effort. The plan was that we were to start in August 2019 with the preparations. Then we would start development around September, October. Then we would do development up until Christmas when we wouldn't do anything. And then we would enter testing and QA in February. The application form would be live in the 1st of April because that's when the first round started. And then the back office would be ready to process requests in June 2020. This was the original plan. We went for Scrum because everybody does. And 2-week sprints. We had Jira as issue management. 2 projects there, one for design, used by our UX guys, and another one for developers, used to actually implement all the ready designs. And this was the environment. So we were talking about a government organization. They are not in the cloud. So we are actually dealing with self-hosted Windows services. No containers anywhere. All the applications have to be installed as Windows services inside a Windows machine. We ended up with 2 similar environments, one for QA and one for production. We had the application form running inside a demilitarized zone because it was going to be used by the applicant organizations from the outside world. And then we had the rest running on the internal network. And then there was also a customer-provided CI server running Team City. And us outside developers, we could access these servers, but we first had to connect to a VPN, and then we had to use Microsoft Remote Desktop to log on into these servers in order to be able to do something. We used the same deployment model as this customer had always used. So essentially, whenever you pushed to a specific branch, Team City would react, build it, and deploy it. So if you pushed to the master branch, it would deploy to the production environment the next night. And if you pushed to a release branch, it would deploy to the QA environment immediately. Well, we all know what happened in 2020. So our plans basically went out the window. We all had to start working remotely, which in a way wasn't a problem because we were working remotely anyway, since this customer was in another country. Problem was, of course, that not only did we have to do our daily work, but we had all our kids at home with us as well, and all the other stress with not knowing what the situation was gonna look like in the future. Fortunately, the customer and us, we were hit at the same time. So we were all in the same boat, which really helped. Now, the customer being tasked with supporting non-profit organizations got new orders from the government. So now we're going to have to start distributing money, lots of money, to these non-functional, non-profit organizations that are not able to collect money because of all the lockdowns. So that means our original schedule is put on hold, our original plans are put on hold, and now it's time to test this platform feature. So how easy is it to use this platform to build a new scheme? Actually, not one new scheme, 4 new schemes. And eventually, a couple of later, 4 additional schemes. So I can reveal that already what started out was 2 schemes, ended up with 10 schemes. This turned out to be more difficult than I would have been comfortable with. First of all, whenever we did a redeployment, we actually redeployed everything because it was a single repository and this was reacting to pushes, so we redeployed the application form, redeployed the back office, and since it was a monolith, it meant that whenever we deployed and made changes to one scheme, it would redeploy the entire system. Not only this, the build time kept increasing and increasing and increasing. We were talking about over 20 minutes per build, which was really frustrated. If you first waited 20 minutes and then you realized you had made a single line code mistake, and then you had to fix it, and then you had to wait another 20 minutes to get this QA out, and so on. We also run into problems with our monolithic design, because even though we had tried to keep it like really modular on a code base level, so that the dependencies were always pointing in the correct direction, turns out everything was coupled on the database level, because and here's some Java technology again. Even though we had multiple modules, they were all sharing the same Java persistence context and the same single database. And of course, we were using inheritance. So if you're doing a query on an abstract class in JPA and it has multiple concrete classes, some of them coming from different modules, and then it finds a class that it doesn't recognize because that class doesn't happen to be in the class path at that particular time, then it will just crash. So you could actually break stuff in completely different parts of the application depending on what you stored in the database. And of course, all our reusable classes were not reusable because the schemes that we had all assumed would be quite similar were not similar. So we had to do something. First attempt that we did was to separate the databases so that each scheme would have its own database, but we still wanted to keep it inside the same singular monolith. So we figured that, all right, every application is its own Spring Boot application. Now Spring has application contexts, and application contexts can be nested. So let's try to introduce a master main application context for all the shared stuff, and then each scheme would have a child context which would contain its own persistence unit, its own transaction manager, its own database, and so on, and everything is fine. Everything was not fine. Spring didn't like this at all. It fought back from day one. And also it turned out that these contexts actually didn't behave the way we had assumed that they would. So never base system design decisions on assumptions if you're not sure that they are actually true, because in this case they weren't. What we ended up doing was making a complete mess of the entire code base. And we didn't accomplish any of our goals. And then my colleague said some very wise words that I always quote: if the system fights back, you're doing something wrong. So it was time to try something else. Now, when I talk about microservices now, and if I were to explain what it actually is, the purists among you would probably really not agree with me at all. So this is like a more of a microservices inspired approach than a pure microservices approach. We had thought about this before the project started, so we were like thinking, are we going to go down a microservices inspired approach, or are we going to go for a monolithic approach? But we had never done anything microservice like before, and we knew that we're short on time, so we decided to take the safe route and go for the monolith, because we thought it would be safer and easier, which it wasn't. Right, so this is our new idea that we decided to go for. So we would split up all the schemes into separate Java applications, so that for each scheme we would have a separate application form application and a separate back office application, and they would all have their own databases, and then we would access them through gateways. And in the gateways we would then put some common stuff like authentication and so on, because we had to integrate with various types of authentication systems. So we figured it would be easier to do it on the edge instead of having to re-implement it in every single application. And we also built some supporting services. We also needed a new environment, because we now had a less than a year-old legacy environment with a messy code base that we didn't want to touch. So we decided to set up a completely new environment. It looked like this. So again, no cloud. So all these boxes here are Windows servers, self-contained host. Actually, I think they are virtual, but still they were like Windows servers. We had only the gateways in the demilitarized zone that were accessible to the public, and we moved all the other stuff into the same internal network, which actually made a lot of things easier. And then we had separate servers running the application forms, and then other servers running the back offices, and then some databases and so on. And of course QA and production, which were almost identical. We also decided to split up our repositories, so that instead of having a single GitHub repository with a single Maven monster project, we split it up so that each module got its own repository. So every shared library had its own repository, every application had its own repository, because we were still deploying by merging to the master branch, and we didn't want to deploy everything when we made a change to a single module. And of course, we now needed some place to store our shared libraries, because we couldn't build them as part of the main build anymore. We did a detour with like sub-Git repositories, but that didn't work at all. So we ended up with GitHub packages and GitHub actions, because we could do them, we could have these packages. They were private, but they were accessible both from the outside world, so by us, Vaadin developers, and by the customers' developers on the inside. And then in order to deploy these, we created GitHub actions that then built these Maven modules and deployed them. And in the beginning, this was not a smooth ride. We messed things up. We pushed stuff to the wrong repository. We deployed to the wrong repository. And we managed to trigger a bug inside GitHub itself, a regex bug, because of how the way we were versioning our modules. It was quite frustrated until they told us that, all right, this is our fault, and they had to fix it. And eventually it started to work. Also, because these were all protected, we had to have tokens everywhere, and it took some time to get the tokens right and used wherever they needed while keeping them at least somewhat protected. This approach introduced a new problem, which I call the snapshot problem. So, we had a rule that you can't deploy snapshots to production, which meant that before every production release, you had to make sure that you have made releases of all the libraries as well. And since we had lots of libraries, it meant we had lots of snapshots, which depended on snapshots, which depended on snapshots. So you had to go through this entire chain every time in order to deploy something to production and make proper releases of them, and then sort of backtrack until you reached the application, and then you could make a release of that. In the worst case, this meant like several hours of manual labor. And if you did something wrong, you messed up a merge somewhere, then it wouldn't work. So we decided a version is just a number. We're not going to deploy library snapshots anymore. We're just going to deploy releases. So every push is a new release. We're just going to increment the number and forget about the snapshots. This worked pretty well, actually, except that we ended up with a shitload, of versions. And it became quite difficult to keep track of, like, was this now version 23 or 24 or 25? And which version is used where? And which version is being pointed to by which dependency and which application and so on. So this started to become quite difficult. We also had another problem. I already mentioned that we tried to make like reusable libraries to reuse as much code as possible, but it turns out that this wasn't possible because, again, we had made the designs and the assumption that these different schemes would all be similar, and they were similar enough but not quite similar. So we often ended up in a situation where you would have to make a change to a base class which would break all the other schemes. So eventually we started to do coding by copy-paste. So instead of having these shared libraries, we would just copy the libraries into the applications. And at one point we even changed it so that we could copy an entire application every time we started a new one. And then we would just make the changes that needed, remove the stuff that wasn't needed. And this actually worked pretty well. Now, mind you, most of the applications we are building here, we know are throwaway. So we know that this is a one-time payment only because of the pandemic. So it's only going to be alive for a couple of months. So that means that we can do like throwaway coding with a good conscience. And that also meant that we were essentially prototyping in production. So every application became a little bit better because we always knew that, all right, in this version we screwed this one up. Well, let's fix it in the next one, which will go live next month, and so on, and so on, and so on. So this made our applications really flexible, but the problem was when you found a bug in a base class and you have to go back and patch it everywhere because it was now copy-pasted. So, of course, there's no such thing as a free lunch. Automatic testing also suffered. We didn't bother write any automatic tests since we knew that the code is going to be thrown away a couple of months anyway, and we're on a tight schedule. So we had QA testing done by our POs manually, and it also worked in this particular case. It was good enough. By now, our deployment model is causing problems. So like I said, we were deploying by pushing to branches, and this was then triggering different actions in our CI server. Configuring the CI server wasn't easy because it's TeamCity. So every time you had to configure a new application, it took some time to get all the configuration right, to get the deployment script right. And also the licensed limit of project was quickly approaching, so at one point we had to sort of figure out that which projects can we delete now in order to get new one into TeamCity, so that we don't have to go to the next level and pay a lot of money. Also, sometimes a build would fail because some of our testing, especially the integration tests, sometimes they failed, sometimes they passed. And then you had to trigger a new build by pushing some kind of, touching a file, pushing it to the branch and waiting for the CI server to trigger the next build and wait 20 minutes and hope for the best. All the branching was also still done manually, so you had to keep track of which goes into the master branch, which goes into the release branch, this goes to the QA, this goes to the develop branch. Have to merge everything back so that I don't lose any changes, and if I do a mistake, well, something will go wrong. So we had to again do something different. So we decided that, all right, a release is not the same as a deployment. We have to separate these two. So it should be possible to make a release without automatically deploying it anywhere, and should also be possible to deploy any release to any environment depending on what we want to do. So for instance, if we have a working version in QA, we don't necessarily want to build an exact copy of that code with the release candidate suffix removed just to be able to deploy it to production. We could just deploy it to production since it works. So we decided to do a releases by tagging instead of pushing to branches. And at the same time, we changed and simplified our branching model so that essentially we just had a main branch which we were working against. And if you wanted to use a release branch in order to prepare a release, you could do that. If you didn't need a release branch, you could just work on the main branch. And whenever you made a release, it was just a tag. And then we had like different naming for these tags. So we could have release candidate tags, we could have release tags, we could have hotfix tags, and so on. And at the same time, we ditched the TeamCity server. We introduced the GitHub actions and GitHub releases instead, so that whenever you pushed a tag, there was a GitHub action that would trigger and create a GitHub release that contained the installation package for this particular application. This was a step in the right direction, but it still involved quite a lot of manual work. So we figured, all right, we have to automate it some way. Maven has a release plugin, but it did not fit our requirements, so we wrote our own. So now we have our own Maven plugin that automates a lot of this work. So it does the POM file changes, it upgrades, increments the version numbers automatically, it does all the JIT operations, it branches, it tags, and so on. The only thing we didn't dare to let the Maven plugin do was push and merge. Those operations were still had to be done manually by a developer. But otherwise, this turned out to work really, really well. So from having to do lots of manual work, you could now create a new release in seconds. And then you just did a push and checked that everything went fine, and then GitHub action would trigger in, and like 6 minutes later, we would have a release containing an installation package on GitHub. Now, since we were no longer deploying automatically, we had another problem that we could finally address. As you remember, we went from one repository into a shitload, of repositories. This turned out to be a problem for productivity because the developers had to have lots of IDE windows open at the same time, each working in their own projects with their own repositories. And whenever you made a change somewhere, you had to build it, go into the next window, refresh, do the changes, next window, refresh, jump between these windows. The developers started to complain. So now we decided to backtrack again, so we went back to some kind of like monorepos, scheme-specific monorepos, so that each scheme would get its own repository that would contain the application form, the back office, and the shared libraries. but they would all have their own version spaces. So we had like a prefix tag. So you could deploy different versions of the application form, different versions of back office, and so on, even though they were all in the same repository. And this also worked pretty well. So now we have essentially everything on GitHub. We have our source code is there, we have all of our Maven libraries are there, we have our installation packages there. Now we need a way of deploying them. And the servers are all running on the inside the corporate network, whereas everything else is on the outside, including us. And of course, it was possible to go through the VPN, remote connect, so on, blah, 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 in order to log into Teams to manually trigger jobs there. But we figured there has to be a better way to do this. So we wrote a Slack bot. Now, I was looking for different solutions to this problem. I figured that we can't be the first team that has to deal with this. So I ran into, I think it was either a conference talk on YouTube or it was an article somewhere that they were using Slack to deploy. So I figured, sounds like an interesting idea. So I decided to pick up the JavaScript API of Slack and start reading about how to write bots, and we ended up with something like this. So we had a Slack bot running on the internal network, which was connected to Slack API through a WebSocket. And then inside a special Slack channel, we could issue special commands like deploy this release to this environment. And then the Slack bot would take this command and it would execute it. It would download the correct installation package from GitHub. Then it would issue a PowerShell script, because we're still on Windows, which would then unpack and install and start up this installation package on a server. And then it would send the output back to Slack so that we can see if everything went fine, the application was up and running. If something went wrong, we would have to remote desktop into the server and fix it manually. This also worked really nicely. So it turned out this was a good idea. It took some time to get it right, but eventually we got there. Right. By now, we were no longer working on a single product like we had started on. We were actually working on an entire ecosystem. So we had lots of moving parts, and you all know that when there's lots of moving parts, there are a lot of things that can go wrong. Even though we had, of course, tried to make things as resilient as possible. So we had to adopt a DevOps mindset. So previously we had all been used to like, we're just writing software and then we're handing it over to some IT department which will keep it running. In this case, we had to be responsible for essentially producing an entire service. So we're not just producing a product, we're producing a service. We are responsible for writing the code. We are responsible for keeping it up and running in production. Which means that us Java developers now have to learn how to administer Windows servers and how to code in PowerShell, which was a horrible experience coming from a Unix background, but I survived. We also had to create our own monitoring and alerting systems so that we would get warnings on Slack whenever something started to behave strangely in any servers on production. And it was an interesting experience, let's put it like that. The interesting thing, of course, here meant that whenever something went wrong, we all took our jobs really seriously, of course, so the entire team would drop whatever they were working on and immediately rush to the production servers to see what was wrong. We did manage to get most problems solved really quickly, but this also affected our productivity in a negative way. So we had to name a developer on duty for the week, which would then be the guy responsible for reacting to production issues and going in, doing the initial triage and assessment. And if they managed to get it fixed, then they would fix it. And then if they needed the help of the team, they would escalate it. And this worked pretty well as well. And we managed to get some piece of work into the team again. Right, the meeting day problem. So by now we were still in doing Scrum with 2-week sprints. And of course, when you're doing Scrum, you have to have all kinds of meetings. So we had backlog grooming, and we had sprint planning, and we had sprint demos, and we had sprint retros, all on the same day. So we started to refer to this as the meeting day when we wouldn't get any work done at all. And this started to become really annoying for the overall flow of the project. So the first thing that we did was, of course, well, we went from 2-week sprints to 3-week sprints, because then you have a less number of meeting days per month. But then you're just reacting to a system and not actually doing something about the underlying cause. And the meeting day also wasn't the only problem, because we are also starting to have problems with our backlog. So even though we had these meeting days, our backlog wasn't properly groomed. So we didn't have tickets prepared when we needed them. They were not always properly prioritized. And since we were now doing DevOps, it meant that our prioritizations could change on a daily basis. So even though we had originally planned to do something, then something could show up in production and change our plans completely. Which in turn caused problem with our release train, because originally the plan was that we would release after every sprint and then deploy to production, and we didn't. Because of various reasons, we were never ready to have, we never had anything ready for deployment at the end of any sprint. Either we hadn't tested it enough, or the priorities had changed. We always kept moving stuff from the sprint over to the next sprint, over to the next sprint, over to the next sprint. Most of them were stuck in this final, next to final state, ready for delivery, but because it hadn't been tested, we couldn't mark it as done. And well, if you looked at our burn down chart, it basically looked like we weren't getting anything done at all, even though we were working our asses off. Sorry for that language again. So we had to make another change. So we switched to Kanban because we needed to be able to work on multiple projects at the same time. So like I said, we went from 2 schemes to 10 schemes, still the same team. We need to be able to react to changes in priorities on a daily basis. And we want to get rid of all the unnecessary meetings. And we want to make sure that we always have enough tasks that are prepared so that we can start working on them when we are finished whatever it's working on now. And turned out Kanban was the way to do this. So we ended up with a Kanban board that looks like this. So no more meetings. We have no more sprints. We have no more sprint planning. We have no demos. We have no backlog grooming. But we kept the retros and the daily stand-ups because that seemed like a good move, and turns out it was. So every item on the board would go through these steps. So they would start out in the selected for development. So that's the tickets that the POs have chosen that we're going to work on, regardless of which product they are in. And they are ordered by priority. So whatever is at the top of the selected for development is what gets worked on first. And the POs are free to change this order every day, depending on what's happening in production or somewhere else. Then we will move over to the preparation step. As you can see, in typical Kanban, we have like double columns, doing and done, which is really useful. So the preparation is essentially the backlog grooming, but instead of grooming it in a meeting, we're grooming it on a ticket by ticket as a part of the overall process. Eventually, it will get over to the work stage where we actually implement it. Then it will go to the acceptance stage when the PO will test it and make sure it works. And eventually, when it ends up in production, it's delivered. If any ticket doesn't pass acceptance, it goes to the blocked column. If a developer can't proceed, it goes to the blocked column. Now, in addition to having these different steps, Kanban also has min-max limits. So in different columns, you can specify that this column is required to have a minimum of this and this many tickets, or a maximum of this and this many tickets. So that, for instance, means that the blocked column has, of course, a maximum of 0. So that means that whenever we have a blocked task, the column turns red. That's where our attention should go. If the acceptance done column is getting too full, then it turns red. It means we are not deploying to production fast enough. Why aren't we doing this? We need to do a new production deployment. If the done column is filling up and becomes red, it means that we don't have enough testing capacity at the moment. So we have to help out the QA guys doing the testing because it's becoming a bottleneck. And if the done column in preparation is filling up, it essentially means that we're not completing tasks as fast as we should. And also, if the done or doing column is too empty, it means that we haven't prepared enough tasks. So essentially, we could use this to drive our process so that whenever you were finished doing something, you would see that, all right, is there any prepared task that I can start working on, or do I need to go and fetch something from selected for development and start preparing it? So we essentially built this specification preparation stuff into the development process. And this worked really nice. We mostly followed this process. We had to remind ourselves every now and then that what we had agreed on. And it worked a lot better than our previous Scrum process. Jira, of course, put up a fight. But hey, that one we lost. I haven't actually found a tool that I like that can do Kanban properly, so I guess I have to write one myself. Anyway, the end result, we have 10 schemes and 2 supporting applications. We have 22 applications running in production. We have 30 active source code repositories on GitHub and 15 retired. 23 shared libraries. And this was supposed to be a small monolith that started out in 2019. The project is wrapping up now. Last of month is the final project day. The main takeaway, I hope I have given you lots of takeaways already, but if I want to emphasize one, it would be this, dare to explore, which also happens to be one of the core values of Vaadin. So sometimes you just have to step out of your comfort zone and realize that, all right, what we have been doing so far, it just isn't working. And even though everybody else is doing it, it's not working for us. Or even though it worked in our previous project, it's not working in this one. So then you just need to sort of realize that, okay, we have to do something different. And then you go look for, first of all, the root cause, so not just addressing the symptoms. And once you find the root cause, you go and find a cure. Could we have done something better? Of course. I mean, I wouldn't do this in the same way if I had to start it now. But it's getting late, and you'll have to get up early for tomorrow, so I'm just going to end it here. Thank you very much.